Thank you, Mr. Chairman. Dr. Reitze, in 2014, BICEP-2 experiment team announced that they had found evidence of gravitational waves, but the observations were later shown to be the result of galactic dust and were discredited. How confident are you that this or some other type of error is not responsible for the detection of gravitational waves in this case?
Yeah, that's actually an excellent question, and one that we worried very much about ourselves. I think the way, first of all, the thing you can say about it is that we actually had two different detectors. We had the one in Louisiana and the one in Hanford. They're independent. They're operated totally independently. They're uncorrelated. They both saw the same signal. It had the same characteristic in signal. The data that we analyzed from that actually showed that the signal was completely consistent. It was found by many different methods. There were a lot of other checks that were done because, as was mentioned before, there are other things, noises that can creep in. So we looked at our detectors and convinced ourselves that there was nothing that was perturbing our detectors. We also did a statistical analysis without going into much detail. We calculate what's the probability that this could actually be false, and how many, if you had to run for how many years, would you see an event that looked real was false. We couldn't actually put a bound on that number. It's more than 1 in 200,000 years. That said, we also looked at other things. Could somebody have maliciously done an injection? We talked about injections. Could somebody have, secretly hacked into our computers and done this? We checked every path that we could think of, and even some that we couldn't think of after we thought about it a little bit more, and convinced ourselves that no, that was not possible either. So I think the answer to the question is I think we're very confident. I would say this too, we expect to see more of these signals. So we hope that in the next, the data that we still have sitting, we're analyzing it right now, that we'll see more of them, and having more of them gives you confidence.
Let me give you somewhat of a follow-up on that, and any of you can answer this, and that's the practical application of this, because as my colleague, Mr. Massey from Kentucky, and I were discussing, GPS doesn't work without relativity. Do you see any practical application of this? And I'm not implying that this is not valuable for the sake of science and science. What would any of you see as a practical application? That doesn't mean my time's up.
Yeah. of detecting gravitational waves. It's hard to see anything in the short term. Some people, for example, thought about you might be able to use them for communication because they go through everything. I mean, my body's being bathed by gravitational waves right now. But it turns out that to generate them, you need big, huge black holes. So it's hard to see that. I think in the short term, and I feel more confident talking about the short term, the things that we'll see that will come out of this research are the technology transfers that come from the work that we do to build these detectors in computing and optics and lasers, servo controls, vacuum systems, things like that. Fundamentally, it's hard to see, but again, for me, this is inspirational because it allows us to see the universe in a way we've never seen before, and for all of us, that's why we got into science. That's why we like to do it.
I really love the GPS mention that you make, because it's certainly the case that when Einstein did general relativity, he had no idea it was going to help me find a Starbucks. and it really is, there are remarkable things like that in the future, but as I said before, I wish I could tell you which one. I think we all do, but they're out there.
I have to credit Mr. Massey with that question. It helps to sit by a physicist from MIT. Engineer, okay. Dr. Shoemaker, not long after the announcement on February 11th, the Indian cabinet granted approval for LIGO India project. Can you give us an idea of the impact of additional observatories coming online?
Yes. The really wonderful thing about the India opportunity is that it's in the far to the south of all of the other existing detectors. We have the Hanford, Washington, and Livingston, Louisiana detectors. There's the Virgo detector from Italy, which is in Pisa. There's Kagra, which is a Japanese detector. But if you look from a big distance from the Earth, they're all pretty much in a line. And the wonderful thing about the India site is that it's to the south of that. And that gives us a bigger tripod that we can use to look in the sky and try to localize the source of a gravitational wave. And it will have a remarkable and unique effect on our ability to pinpoint in the sky.
Thank you, Mr. Chairman. My time has expired.
Thank you, Mr. Palmer. And the gentlewoman from Massachusetts.